Martin over there. He's waving his hand. And Tower is a hassle-free data platform for data engineers. But today, I thought I would talk a little bit about something different than data management. I want to talk about integration of Iceberg with AI. And so the purpose of the talk is to talk about local and serverless inference with DeepSeek R1 using Iceberg Lakehouses. In the talk, we'll first explain why local inference does even make sense. Who of you here is doing ML with Iceberg? Any inference people? All right, well, you'll learn something today. Oh, not right yet. So then we're gonna kind of explain why inference with Iceberg actually makes sense. We're gonna explain or look at the different market trends and tools that make everything possible. Local inference on Iceberg, local and serverless inference on Iceberg. And we'll have a short demo, and we'll conclude and go and have more drinks. So, why local inference? Why does it even make sense? If you were a developer who was dealing with ML, including data, you would probably run something on GPUs available to you, made available to you by an employer in the cloud. This is the typical deployment model. You can either have dedicated GPUs available to you, or you use a serverless inference provider. The consequence of you using these GPUs in the cloud is that you use the same stack in development as in production. The downside of this approach is that you get throttling, and you get network latency. You get contention when you have to share the same resource with other developers. And by the way, we are talking about development use cases here. We're not talking about production, where everything needs to be high performance, and there's only one job that does inference. We're talking about 5 developers trying to run the same inference job simultaneously, debug it, improve it iteratively, one after another. So you get contention because you have to compete for the same resources with your buddies. If you're not using dedicated resources, if you're using serverless providers, you get the other problem of throttling, because someone needs to do contention management, and that's the serverless provider. In any case, you will get network latency. It doesn't really matter in production use cases because everything runs in the cloud, but when you have your laptop and you have your serverless provider, you ultimately get a delay during debugging, during development. GPU costs are still high, availability is not assured, and there's this last problem of not every data is allowed to go to the cloud. So because of this, lots of developers are asking themselves, can we use our beautiful MacBooks, or if you use Windows with NVIDIA, can we use our beautiful development machines to use local GPUs for inference and still run our production workloads on NVIDIA in the cloud? Now, how does Open Lakehouses fit into it? Well, data for inference needs to be stored somewhere. Your features need to live somewhere. So storage is needed. You only have a choice of either storing your data in a lakehouse or storing it somewhere else. Now, we'll see later in this talk that the compute stacks for local inference and production inference will differ. And so I'll make a statement here that Open Lakehouses are actually the best storage facility that can handle the differences in compute stacks between development and production. And that's one of the key points why I wanted to bring together inference and lakehouses. Let's go through a couple of blockers that used to be true in the past, but actually are not true anymore. Blockers for local inference during development. One blocker was that the best models were actually proprietary and not available to anyone to use locally on your machine. And this is changing dramatically. Both Llama 3, that was released last year, DeepSeek R1, that was released 3 months ago, now Meta released Llama 4. So the best models are now available in open source and available for you for download on your local machine. And they're actually pretty good. If you look at the benchmarks, they sometimes beat or definitely match the performance of commercial models. The other blocker that used to be there but is not as significant anymore is that model sizes are growing. Model size is usually a combination of how many parameters you have in a model multiplied by the number of bytes you need to store this model in memory. And there are two techniques that are enabling you to still use that DeepSeek R1 model, the wonderful R1 that gives the same performance as the most expensive OpenAI's model. The one technique is called distillation. Distillation is the process of creating models that have a smaller number of parameters. So you end up with variants of 2 billion parameters instead of 670. You can get a 14 billion model, a 17 billion parameter model. So these models have less parameters, they're not as accurate, but they can fit your hardware. And the other technique is called quantization. And this is the process of reducing the number of bytes you need per parameter in memory. And there are versions here that reduce one parameter to just 4 bits instead of a full byte, and even 1.73 bits. That's another talk. How do you fit a particular number into 1.73 bits? And so all of this means that you can get your models down to very small sizes. And the other consequence is you can get pretty good models, full models, into reasonable sizes that they can still run on your desk. Now let's actually talk about what you can run today on your desk. So many of us use Macs, and Macs give you up to 128 gigabytes of RAM. This will fit a pretty sophisticated 70 billion parameter version of DeepSeek R1. Now, last month, both Apple and NVIDIA released 2 new desktop devices, which actually allow you to put pretty sophisticated versions of the models on them, and they cost less than $10,000. Now, let's talk about the second last blocker that used to be true but is not true anymore. Apple's hardware was actually not very good for ML inference. This is changing by the new local servers that are coming out. There's a whole cottage industry of local inference servers that is available to developers now. It started with the Llama CPV project, which then was the basis of Llama. There's the VLLM local inference server. All of these servers deal with the deficiencies of Apple's NPS platform and allow you to do pretty performant and easy to use inference locally. So this brings us to the last challenge, many more, but let's say for this talk it's the last challenge, where we realize that yes, we can run inference, yes, our compute stacks will be different. In production we'll use NVIDIA, and locally during development we'll use our Apple GPUs. We'll have to use different inference servers. So these compute stacks are pretty different, and developers don't like different. They like things to be the same, because different means debugging will be hell. There are a couple of approaches, or two approaches that folks tried to do or try in the past. One was packaging these applications into Docker containers. That's a typical approach. Unfortunately, you can't have three of these three beautiful things. You can't have Docker, apps in Docker. You can't have them running on macOS and them using GPUs. You can only have two of the three, but not three together. It's very weird, has been a problem for years, and probably will not be solved for a long time. The other thing was, folks tried that, well, if you can't bring the mountain to Muhammad, then we'll bring Muhammad to the mountain, and so they tried to use Macs in production, which is also possible, super expensive, not scalable, but possible. For reasons of non-scalability and expense, folks are not doing it really on a large scale. So the solution that does work is using a runtime, an application runtime that doesn't use containers. It uses a different approach of packaging your applications and synchronizes the environments. Tower is actually one of these solutions. We're not the only ones, but we definitely is one of them. So what we do is we provide you a storage and compute environment, and we don't use containers, we use virtual environments, we synchronize them between prod and dev, and we allow for differences between these environments. So you can have small differences between dev and prod, And these differences make the difference. You can use GPUs on your local hardware. So I wanted to show you a demo. How much time do we have? Probably a few minutes. So in this demo, great, so we have the time. In this demo, I wanted to take a use case of a GitHub issue. It's actually a Apache Iceberg issue. So someone submitted a request to add a shuttle clone to Iceberg. There was a whole discussion about this topic, so like 15 different comments from the original creator of the issue, from the repo maintainer, from all the community members. Pretty great discussion, but it was long. So what I personally would want as a developer of this feature, I would want a summary of the feature. What was the motivation of the user for it? What is the goal? What is the user asking me to do? Can you please summarize all the different and good discussion points in this topic? Can you perhaps give me some options for addressing this problem? So kind of a nice little report that shows me the summary of that discussion on GitHub. We'll use a trick. We'll actually convert that GitHub issue into a LLM chat. And if we can convert it into a chat, then we can use our beautiful DeepSeek R1 to do the summary and create us a great recommendation. And there are a couple of other little tricks that we use. For example, the prompt will say something like, summarize this GitHub issue and identify options for addressing the original issue. Output as markdown. The issue itself will be the first message in the chat. Then all of the comments by the contributors of the repo will mark them as assistant messages. That's a trick. And all the other messages will be, again, converted, all of the other comments in the GitHub thread will be converted into messages. Well, great, so we have this chat, and we developed a demo pipeline that actually consists of 3 pipelines. The first pipeline on the left is a simple ETL pipeline. It sucks in data, it acquires data from GitHub, every issue gets imported, there's no AI there, it just dumps, converts GitHub issues into chats, stores them in Iceberg. Now, the other 2 jobs are inference jobs. And I can run the middle job locally on my Mac, and it will use a certain stack for inference. It will use the smaller version of DeepSeek R1, the 14 billion parameter version. It will be served by Ollama, and it will run on my Mac Silicon GPUs. Whereas the production job will actually run in the Amazon cloud. It will use a serverless provider to gather AI. It will use the full DeepSeek R1 model. And so let me show you how all this works. We'll first start Ollama. Sorry for the quality, it will get better over time. So we'll first start Ollama. And then the next step is to run our first inference job, the development job, in the local mode. And so the point of this demo is to show you, if you could actually read this, if you track the GPU consumption, now your GPU, your local GPU is fully consumed by Ollama, inference is being done locally. About 85% of the GPU. And then the model spits out the results, and I have my nice little summary, exactly what I wanted to get. I get my options, there's the summary of the issue, the options, solution options that I can apply to implement the original request. And in the next step, I will run the same inference job now in production, and the difference will be I will use the full DeepSeek R1 model, and I will use a serverless inference provider, the Together AI inference provider. So this job will actually complete very quickly, and the reason of that is, of course, because it's submitted to the cloud and being run in the cloud. This is the interface of Tower. Just wanted to show you the same output being produced by your cloud job that uses Together AI to do the full inference on the chat. The output looks exactly the same. It's not exactly the same because I'm using the full model. It's much better. So there's a reason why you would want to use the full model. But in development, it was fine for me to use a very simplified version of the model. Well, great. So we have a couple of resources here. If you're just getting into the AI game on Iceberg, check out Hugging Face. There's a bunch of good open source models. Use Olama for local inference. There are other providers like VLLM. Tower.dev gives you this application runtime that is compatible between the two environments. And I wrote a blog about local inference with DeepSeek R1. So if you want to read it instead of me just listening to me talking about this, you can read it on the blog. Thank you.